Namaste. All right, good morning, guys. All right, I just wanted to make a quick video to kind of back up or some concepts on gravity and black holes, and I also just wanted to clarify the instruction that I wanted to give you for the, or at least part of the assignment that I wanted to give you guys today. So here it goes, all right? And take notes on this just like you'd be taking notes in class, all right? And so let's start off with the concept of black holes. Let me get my pointer. Okay, so black holes. And what a black hole is, and you should have a bit of a background by now, is it happens when a supermassive star, a star that is much bigger than our sun, eventually dies, okay? And the core collapses, okay? The outer layers are shut out, and that happens in what's called a supernova explosion. And then the outer layers go into class, and they become a nebula, or go into space. Hello, all right, and they go into space, and then the inner part, which is still very massive, collapses, and it keeps on shrinking and shrinking and shrinking, and we don't know what happens to it. The theory is that it shrinks infinitely. How do you take something the size of a massive, massive star and shrink it smaller than an atom, smaller than a proton? Nobody knows, but at least in theory that happens. And the universe is kind of a weird place, so we're going to go with it. Again, we don't even know where the universe came from. It seemed to have started simply out of nothing in an event called the Big Bang. So as long as we're getting weird, just kind of go with it. A star, as far as we know, a large star, when it collapses, if it's big enough, when it dies, will shrink to nothing. But yet, the mass and the gravity will still be there, okay? All right, so, and when this happens, we call it a black hole. And why is a black hole black? Well, because a hole is black because even light itself traveling at the speed of light, and if you remember, you should have watched the video on the guy with the sheet of spandex, and he put the ball in there, and then you put another ball, and what that represents is space curving. And so the ball in the center, the larger one, or the weight in the center, curves the spandex, which represents the space around it being curved. You throw a ball bearing around it, it's trying to go straight, but it winds up curving because the space that it's traveling through is actually curved, okay? So if you can imagine the weight on that spandex staying the same weight but getting smaller and smaller and smaller, down to the size of a BB, but still has the same weight, it would stretch that spandex way the heck down there, and the curvature become really, really massively curved, okay? And that's kind of how we envision the space around a black hole. At a certain point, if light gets within a certain distance of a black hole, it doesn't come out. And that's why black holes are black. They're truly black outfits, not like my sweater that I'm wearing where some of the light bounces off of it and you can see it absorbs a lot, but not all of it. A black hole is truly black because no light reflects off of this thing, okay? All right, so the distance around a black hole, and the black hole will be in the center, okay, which again is an object that we don't know exactly what that is, what happened to the star, or whatever, but we just know that the gravity is still there. The center part would be called the singularity. Which hopefully I fit into the board there. Okay, and at a certain distance around the black hole, all right, we call this the event horizon, okay? The event horizon, and write this down, is the distance from a black hole where if light gets within that distance, light itself will not come out, okay? So that's what it is, all right? And that's, Now, to elaborate, something else happens around the black hole that's kind of weird. Gravity itself, and let me talk about this. Listen to this and take this down. Gravity slows down time. Gravity slows down time. The effect is called time dilation. Okay, and time dilation is the term we give to the slowing down of time by gravity, okay? And you're probably saying, like, how does that happen? How can that happen? Don't know, but it does. It was theorized by Einstein in his theory of relativity, okay? And we do know it happens. This is not, we have evidence for this. This, in fact, there's a device that's in your house, and I'll tell you this in a minute, that you use all the time that uses this concept of time dilation, all right? So what it means is that gravity okay. So if, to describe this, if you and your friend and you have, you know, the clocks on your phones and you synchronize, so you guys have clocks on your phones and you synchronize your clocks so that they're exactly synced. In fact, they probably already are, because the phones get it from an atomic clock, all right, that's broadcast over the through the internet, and that's how they synchronize. And so let's say they're on Earth and they synchronize, then we take it, now you're standing on Earth and you're closer to being on the surface of the Earth, you're closer to the center of mass of the Earth where the gravity actually is produced. And let's say we take your friend and he goes out in the space. So here you are, okay, you're on Earth. And there's your phone and you have your clock on it, and then we take your bud and he goes out into space. And he's got his phone, and then he's out in space, so he's farther away from the Earth, so he feels less gravity, because that's the way gravity works. The farther you get away from it, the less it pulls on you, the less pull you feel. Or, to go with the example of the spandex sheet, the less curvature of space-time it's in. Okay? And notice I'm using the word space-time. All right? Einstein said space and time are really one thing. You can't separate the two. Not to get into this too much, but a universe, if you didn't have time in a universe, that would be a very boring universe. Nothing can happen. Because once something happens, time begins to flow. All right? When the event happens is, you know, the present. When you get farther away from that, the event, we say that the event happened in the past, and so there's a past, and then there's a future, and there's a present. A universe without space is simply meaningless. So, space-time. All right, anyway, to get back to the example, when this guy comes back down on Earth, you would notice that his clock is actually behind yours. So your clock might be at 9:07, and then when he comes back, you would notice that his clock, even though they were synchronized and he didn't touch it, would be sometime later. It would be, or earlier. It would be, might be at 9:04. Why? What happened? He experienced less time than you did. There's a movie called Interstellar. If you've seen it, it's a good one, where they, you know, these astronauts from Earth are trying to save the Earth, and they go out to this black hole called Gargantua, and every hour that they spend around there is 7 years on Earth. And then the one astronaut, he goes back, all right, and he sees, you know, his daughter, and, you know, he spends some time there, and his daughter, who was, you know, a girl, like, you know, like 12 or something when he left, is now an old woman. Okay, and yet he's still pretty much the same age, because he only experienced like a day or so of time, but yet she experienced her whole lifetime. Does that happen? Yes, it does. Okay, now the reality is, when we go out in orbit, we're really not that far from the Earth. So astronauts that go out in orbit do not really notice the effect of time dilation. Okay, it's when they come back, they're really only a few nanoseconds behind everyone else on Earth, which you can't really notice. Okay, but I'll tell you what can notice it. All right, and that's on your device right here. This can notice it, okay? In fact, the concept of GPS, all right, when you use GPS on your phone, the GPS comes from the fact that you have satellites going around the Earth, and they're in orbit. So there's your satellite, there's your GPS satellite, and it's sending out a signal like that, and you get a Doppler effect from that, and that's by the Doppler effect from the satellites. That's how your phone can pinpoint where you are, or at least Google can, or whatever, okay, on Earth. But the bottom line is the clocks on these satellites are running slower than the clocks down on the surface of Earth. Not that you'd notice, because it's only a few nanoseconds every single hour, but the phone notices that. And so what happens is when they started to set up the GPS system, they noticed that it was constantly, it started off okay, it started off that it was working, but then after a few days, a few weeks, it became less and less accurate. Why? Because the engineers didn't take into account the fact that time up there, farther away from the Earth, is actually running slower. And the satellite clocks, and the satellite clock and the clock on your phone have to be synchronized for GPS to work. So GPS actually uses this concept of time dilation. Okay? All right. So I just wanted to clear that up for you guys, because there's some, just some concepts there that might be kind of tough to understand. Ask me questions when we do when I do my office hours, and say, hey, Golis, explain that again, and I'll try and do that for you. All right. What the part of the activity I wanted you to do, one, I wanted you to make a Quizlet. The second activity I wanted you to do is kind of mimic the guy with the spandex sheet in your house. I don't think this will take a lot, all right? So here, okay, go find, all right, a bed sheet. This is, you can probably even do it. Now you're probably gonna have to grab someone in your house, so grab mom or dad, or grab a brother or sister, okay? Or you might even be able to even just do it on your bed, okay, or something like that, and just make your bed and the surface of your bed like really tight. And then go find a couple of objects in your house, okay, that'll work, and try and mimic the spandex sheet. So you could use a basketball as maybe like the star, okay, and then maybe baseball is like a planet, okay. Or some variation of it. Now you can do a smaller version of it. This is a pillowcase. Okay, this would work, I'm sure. All right, I'm sure you can make it work. Just have someone hold it, and then put like whatever. Maybe you got like a ball bearing or something like that, a metal ball or golf ball will work, and then maybe a BB around it. Do some variation of it. Think it out. Okay, and try and demonstrate what the guy did on the spandex sheet. Okay. Now I'm using this, or you could use this if you're more ambitious, all right, and you can grab some more people maybe, then try and stretch out a bed sheet. This, which I have still folded up, okay, and it was on the floor. I snuck it out of the closet because my wife gets mad if I get these dirty. So anyway, so try that out and all I need you to do, if you want to make a small video of that, great, and then put it on Classroom along with your Quizlet notes, or you can, just seriously just take a screenshot or two, or a picture or two of your setup to show me that you did it. And you're good. Cool with that? Okay. Also, if you don't want to do a Quizlet, if there's some other, flashcards and you want to do that too, and then give me a picture of flashcards that you made, that's fine too. The point is that I see you taking notes and I see you doing something and doing some sort of activity to kind of reinforce the lesson that I taught you. Okay, sorry, this video went on way too long, but all right, okay. So we'll see you guys, and remember, have a fun apocalypse, all right? Goal us out.